Look at this. A cyclist moves along a horizontal road at a constant speed. She then moves at the same speed, okay, up a hill with a constant gradient. Which of the following? Look at this. To answer a question like this, you know that as we studied yesterday, that the power, we can say that equals F times V. Okay. You remember when we said that power equals work over time, the work equals force times displacement over time. Displacement over time is the velocity, or distance over time is the speed. طيب, from here, as long as he is moving at a constant speed, okay, this means he is moving at a constant power. So it can be this B, C, or D. تمام. طيب, now he or she moves up, okay, at a certain gradient like this. Look at this. Now she was moving at a horizontal road with using a certain force. طيب, now she's riding up a hill. This means what? This means she needs more force. Okay, so the force increases, but this power equals force times this time velocity from here, or time speed. The force increases, but the speed is the same. This means the force is not increasing, it just increased to overcome the force of gravity. So she will move at a larger force but constant, because it is against the force of gravity, and it equals the force of gravity, or the component of Earth of the force of gravity acting on her. This means it's a constant force, but it is larger than when she was moving at a horizontal road. This means the force increases, but not increasing. It just increased to be, or to overcome the downward force. This means the force is always increasing for a constant velocity. This one is not correct, because we said that the force increased, okay, to overcome the force of gravity, or the component of the force of gravity. This means the force here becomes larger, but it is constant because it's against a constant force of gravity, or a component of force of gravity. So we'll not use this, we'll not use this. So this one is the correct one, because here the power equals F times V, and here the power equals also F times V. V is the same, but F here is larger, okay, but it's constant, and here F is constant, and V is constant, so the power is constant here, but F is larger when she's going over the gradient. For this one, you know that the weight is acting downward. This means it is balanced by an upward force. This upward force comes from the tension here and tension here. طيب, what is the tension here? The tension is T, or the component of the tension, sorry, it is T cosine, because it is here adjacent to the angle, or parallel to the adjacent to the angle. So this one is T cosine theta, and this one is also T cosine theta. What does this mean? This means the weight equals T cosine theta, which is 80, plus T cosine 80. This means 2T cosine 80 equals the weight. So tension equals weight over T 2 cosine 80. تمام? So the answer is C. For this one, this is the easiest one. You know that they said here the weight is like this, and the is W, and the density is rho. You know that weight equals mg, m equals rho v, v equals, they said here the length. You know that it's cube. The volume of the cube equals length times length times length. This means the volume equals length cube. This means the weight equals the cubed length times density times g. From this, length cube equals weight over rho g. This means length equals the cubed root of weight over rho g. So the answer is cubed root, this one, D. Okay. For this one, wait a second. For each mass added, student determine the force acting the wire. Okay, we have here a graph between the extension and the force. تمام. طيب. The table here gives the Young modulus for some material. Okay, deduce which material the wire was made from. So we have to calculate Young modulus and we compare it with these values to see. It's very simple. You know that Young modulus equals stress over the strain. The stress is F over A over the strain, which is delta X over X. This means F X over delta XA. The gradient here, the gradient equals delta X over force. From this, but we need here F over delta X. Look at this one here. This we need F over delta X and multiplied by X over A. Just a second. Look here. We can get the gradient. I have this point is very clear. Okay, and this point is very clear here. Okay, look at this. The gradient equals rise. The gradient equals rise over run, but here we will get run over rise because we need, look at this, the gradient equals delta X over F, but we need F over delta X. So we get the run over the rise, not the rise over run. Look at the run here. It is from, this one is from here to here, 10 squares equal 10 equal 5. This means each square is 0.5. So this one is 1. And this one is 15. So the run equals 15 minus 1 over the rise, which is 10.4. Okay, because from here to up here, you can see the squares here. The squares are 10. And the 10 means 2 millimeters. This means we have here, this one is 0.2, 0.4, and so on. So this one will be 10 from 0 to up here. It is 10.4 millimeters. This means times 10 power negative 6. Now n equals 14 over 10 power 4.4 times 10 power negative 6. This is what? This is the F over delta X, 14 divided by 10.4. Yes. So we have here, this one is 14 over 10.4 times 10 to the power of negative 3. Now we got this F over delta X multiplied by X over A. X is the length, which is 1.8, over the area. The area equals pi r squared. Pi is, okay, r, this means half of this. Okay, yani 0.085 millimeters. Yani it is pi times 0.085 times, this is millimeter, 10 power negative 3 all squared. So from this we can say that it is 0 pi times 0.08. Okay, pi times 0.085 times 10 power negative 3 all to the power of 2. If you calculate this, you get Young modulus, and it equals 1.07 times 10 to the power of 11 Pascal. This means, gigapascal means 10 power 9. This means it is 107 gigapascal. يعني approximately the one which is very close to it is brass. So it is 1.06 times 10 to the power of 11 Pascal. This means 106 gigapascal. So the material is brass. Don't forget to read this because he's asking about this. Okay. تمام. For this one, you have here the weight, as you know, it acts here in the middle of the door because it's uniform door. This means the weight is acting here downward. The weight equals 14.4 times 9.81 because it equals mg. When you calculate this, it equals, 1 second, it's about 141.26 Newton. And you can say that it is 141 Newton. Okay, this is the weight. The weight acts perpendicular to this axis. This one is half the width, and the width equals 0.85. So this distance is 0.85 over 2, and equals 0.425 meters. This is the weight which acts at this distance. And in equilibrium, the force applied by the force acting horizontally on Y. Okay, and it is acting here. If we consider X is the pivot, we consider all of this distance in the arm. So we can say that this is the force he needs to know. Okay, and we can say that the weight times the 0.425 equals the force multiplied by L, which is 1.6. The weight is 141 times 0.425 equals F times 1.6. From this, you can say that F equals 37.5 يعني approximately 40 Newton. تمام. This is the force acting horizontally to this. تمام. The second point here, they said that the vertical component of the force acting of each hinge on the door is equal to half of the weight of the door. The weight of the door, as we got, it is 141 Newton. Half of it, 141 over 2, يعني equals 70.5 Newton. تمام. We want to get this force. Okay, and the angle. تمام. Look here. It is very easy, inshallah. We can get this one. Look at this. The weight again is acting downwards. These two hinges, okay, support by an upward force. Which, okay, so this one is 70.5, and this one is also 70.5 Newton. Okay, now the weight is down, which is here we can get this one. We got the horizontal force, which is 37.5 Newton. This one is acting, this one is the opposite, and 70 is the adjacent. So we can say that theta or tan theta equals 37.5 over 70.5. So theta equals shift tan or tan minus 1. So 37.5 over 70.5 يعني the angle equals 28 degrees. تمام. طيب we need to get the force. From here we can say that it is very simple. This force acting horizontally equals 37.5, or this one, I think this one is given, خلاص, it says any one of them. You can say that this one is adjacent to the angle, and this one is the hypotenuse. This means we can say that cosine theta equals this force, which is half of the weight, which is 70.5 over this one is here, which is equal to, 1 second. This is F we need to get. You know that cosine equals adjacent over hypotenuse. This means F equals 70.5 over cosine 28. So F equals, 1 second, 70.5 cosine, sorry, 70.5 over cosine 28 equals 79.84 and approximately 80 Newton. So the force is 80 Newton and the angle is 28 degrees.